conditions that we discussed. And the two that are possible are, of course, the one that is orange or the one that is gray. Either you have gray or you have orange. Black does not work, doesn't go through this point. Pink does not work, doesn't go through this point. Either gray or orange. So let's check both. So, starting with gray. The gray one is horizontal parabola. Horizontal means it's x equals ay minus k squared plus h. And we know, of course... Yes, ma'am, Brianna? Go. No, I said orange or gray are possibilities. Black and pink don't work. Alright, so this is one possibility, and we know for the horizontal parabola, a less than 0. We're opening left. For the orange one, that's vertical. Y equals again a less than 0. We're opening left. Regardless of which one is correct, they both have a vertex at 5, -1. So let's just go ahead and plug the vertex into both equations to get a little more cleaner, a little more simplified equation. So I'm going to plug the vertex into both equations. So for gray, I'm going to do gray first. You can go in as any order as you like. Alright. Now, regardless of which one is correct, they both have the point 0, -13.5. They both went through this y-intercept. So let's plug the point in to both equations. Instead of using x, I'll use 0. Now, I didn't know what negative 12.5 squared was, so I have to do that on the calculator. It's okay. Brianna? I'm just plugging in the point into the equation and solving for a. Worry about that later. Worry about that later. Don't lose focus. Alright. So here we have the a from the horizontal equation. This is a legitimate a because we wanted it to be negative, and it is. Now let's see what happens when we go for vertical. Again, plug the point in. And here's the a from the vertical. That also works. So what does this mean? Either equation is a possibility. We just don't have enough information to determine which it is. So you need to write both. So the possibilities are, could have been this gray one with an a value of this. So it could have been that was one option. Or this orange one with negative 0.5. Ryan, go forward with the question, please. Yeah, question. Sure. Abraham? Go for it, buddy.
I think for the graph, if we just plug into the equation for both vertical and horizontal, then find out which one, what is A and then plug it back in.
Hey, that's what we did, right?
It's for like, or if you just do it without the graph drawing it, or
One more time for me.
would you do it without drawing the graph, or?
Yes. I mean, I think it's helpful to draw the picture, but, I mean, if it's not helpful for you, then that's fine. Okay, so let's introduce the last conic, the hyperbola, and we'll introduce some new vocabulary, then we'll do a couple problems. So, hyperbola. Similar in some ways to the ellipse. Well, let's see what it's all about. So, here we go. The hyperbola. The hyperbola. Let me use a better marker. So the hyperbola, again, it can be either vertical or horizontal. So we've seen ellipses, vertical, horizontal, parabolas, hyperbola, same thing. So horizontal hyperbola. And the horizontal hyperbola looks something like the following. You got kind of this, I guess, two parabolas in a sense with some gap, with some space. The general equation for horizontal hyperbola, we call it x minus h squared minus, for ellipse it was plus here, minus y minus k squared over a squared here over b squared here equals 1. General equation. Alright. The ellipse has a center halfway between these branches, so maybe right about here. And of course, this has the point h comma k. So the center h comma k. The distance from center to, we call this the vertex, this distance is a. So a, distance from center to vertex. This is also a. If you double this, we of course get 2a, the distance between the branches. That's called the transverse axis. Then the the hyperbola has two foci, one here, one in here. And we have again this letter C. Remember, C from before was a squared minus b squared. Now C is a squared plus b squared, where C is distance from center to foci. So this distance here, we call it C. This distance here, we call it C. So these are both C. Okay, I'm going to now draw a new picture that's going to label not this stuff, but three new things that I just don't want to clutter this picture with. So are there any questions on this picture, any terminology that's not clear? Okay. So now, let me draw a new picture. I'm going to label three new things. So again, we're like here, we're here, okay, so we talked about how we have the center in here. We have center in here. We oftentimes draw this box here. And here's what happens here. This we talked about already was A, and this was A. Here's where the B comes in. This is B. This is B. And now the box, I just want to be clear. The box is not actually part of the picture. The picture is these two blue pieces. The box is just drawn because it will help us with the asymptotes, so I'm going to talk about in a second. Anyhow, this is B, the distance from the center to the top of the box. This is also B. So this length right here will be 2B. Half B, half B. If you add them up, we get 2B. We call this the conjugate axis. The conjugate axis. And now the last pieces are the hyperbolas have these asymptotes. The hyperbolas have these asymptotes that look like the following. Comes through here, goes this way, comes down this way. And there's another asymptote, comes from here, through this, through the center, through the other edge of the box, and like this. And they make an X. Asymptotes. And these asymptotes have the equation plus or minus. One is positive sloping, one is negative sloping. Plus or minus B over A, X minus H, plus K. I'm now going to do, in effect, the exact same analysis for a vertical hyperbola, but I want to pause here and see if there are any questions before we do the exact same analysis for a vertical hyperbola. Questions?